Hey guys, all of these are the formulas that you're going to need for tomorrow. Take a good look. You have the difference of squares, sum of difference of cubes, the discriminant. You're going to have a couple review questions. One's going to be about the discriminant, one's going to be the quadratic formula. Remember, I'm not giving you equations tomorrow. You need to know the equation for a circle and the vertex form, because you will have all these types of review questions. Sorry it wasn't on the review, but I'm going to upload and go over some review questions that you're going to see tomorrow, and then like I said, I'll post the pictures too. All right. Pause. Hey guys, okay, hopefully I figured out a better way to get these recorded so it's easier for me to upload and that you can get them more regularly. This is going to be our second try, and hopefully I'll get better every time so you can keep getting videos to watch. Okay, I'm going over the review, so hopefully you have it with you. Number 1, identify the transformations of the parent function f of x equals x cubed that produce the graph of the given function g of x. So I'm looking at g of x equals x minus 2 cubed plus 5. Remember, what happens on the inside, that's going to move it left or right, and it's opposite. So the minus 2 means I'm going right 2, and this moves it up or down, which means I'm going up 5. And it's as simple as that. Number 2, I've got g of x equals negative 3 x plus 1 cubed minus 2. The negative, all the negative does is reflect it. So remember that it doesn't actually affect stretch or compression. It just affects if it's right side up or if it's been reflected. So we are reflected. The 3 means it was stretched. This is going to move it left, remember opposite, 1, and then we went down 2. That's all you're going to have for 1 and 2. Number 3. The function g of x equals, all that stuff, is translated 6 units, down 6 units, to produce the graph of the function h of x. Write an equation for h of x. So you're going to take your original equation, and it was translated down 6. So you're just going to combine like terms. X cubed plus 8x squared minus 2x minus 5. And on your test, you're going to look for that answer, all right? 4, 5, 6, and 7. Remember, when we're talking about end behavior, we're just looking at that first leading coefficient, whether it's positive or negative, and we're looking at that leading exponent, whether it's even or odd. So number 4. I have an odd degree polynomial with a negative leading coefficient. So I'm looking at A, B, C, and D for an odd exponent and a negative leading coefficient, and the only thing that matches that is going to be option B. Number 5, f of x equals x to the 5th, all this stuff. I've got an odd exponent, a positive leading coefficient, so that means I'm looking for odd and positive. The only thing that fits that is going to be option D. Number 6. Have an even exponent and a positive leading coefficient. So I'm looking for even exponent, positive leading coefficient. A has a positive 6 leading coefficient and a 4 exponent, so that fits positive and even. So 6 and A go together. And lastly, number 7. I have even and negative, so I look for even and negative, and the only one left is C. So you should have gotten B, D, A, and C. Number 8, we talked about that one. You're not really going to be given a question that asks this like number 8. You're just going to need to understand the properties of end behavior. So remember, we saw this in class. If it's an even function and A is greater than 0, you're going to have both the ends facing up. But if A is less than 0, then both ends are facing down. And then if it's that odd function and it's positive, it does that upward swooshy motion. And if it's negative, it does the downward swooshy motion. Okay. Number 9. The polynomial, blah, 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 can be written as blah, blah, blah. What values of x does a graph of the polynomial cross? Remember, if it gives you a polynomial and it factors it for you, you're just setting each factor equal to 0. So I'm going to take one factor, and I'm going to set it equal to 0. Add 1 to both sides, divide by 3, x equals 1/3. That means it crosses at x equals 1/3. I'm going to do the exact same thing with the other factor, and it also crosses at x equals -5. Let's say you get to the test and you do not remember how to do this. Remember, guys, you can always graph the original polynomial. You can graph 3x squared plus 14x minus 5, see where it crosses, and match that with the multiple choice options.
Jake Rainey, please come to the front office. Grant Lytle, please go to your dad's office.
Please pause for this momentary interruption. No, just kidding. Okay. All right. Number 10, consider the function f of x equals x cubed plus a bunch of other stuff. Find all values of x for which f of x is equal to 0. Remember, when it says f of x equals 0, that means where y is 0, which means it wants to see where it crosses the x-axis. Where does it cross it? Who knows? Okay, so yes, you could try to factor this, but I'm pretty sure the one on the test doesn't factor, just like this one doesn't factor. So you're going to go to your calculator, you're going to graph it, and you're going to see where it crosses the x-axis. So I'm going to show you. So you go to your graph, and you're going to type in x cubed plus 2x squared. Oops. See how it's in the exponent? Don't let it do that. Plus 2x squared minus 23x minus 60. Enter. It crosses at -4, -3, and 5. So those would be your answers. -4, -3, and 5. And that's it. If I remember correctly, on your test it's a multiple select, so just make sure you're selecting all of those, okay? If it's a cubic function, most of the time it's going to have 3 zeros. If it's to the 4th power, most of the time it's going to have 4 zeros, unless there was a bounce or something, and that makes it a little different. But, okay. All right, number 11. X minus 3 is a factor of the function. So it told you it was a factor, which means when you divide, you should get 0. If you don't get 0, you did something wrong. And it says, what are the zeros of the function? So I'm going to divide. Remember, I put the opposite in parentheses. We're on number 11, okay? I put the opposite in my backwards box, so I had x minus 3, so I put plus 3. I write my coefficients across the top. I drop it, multiply, add, multiply, add, multiply. I got 0. That's what I was supposed to get. That means my quotient is x squared plus 4x plus 4. If I want to figure out my remaining zeros from this, I'm going to factor this. Two numbers that multiply to 4 and add to 4 are 2 and 2. And I'm going to set those equal to 0. They're the same thing, so I don't need the other one. That means my zeros of the function is 3, which was given to me, and -2. Those are my zeros, okay? This is a multiple choice on your test. You're just going to pick the multiple choice that has the correct list of those. You can also graph that function. You can graph the fx equals x cubed plus x squared minus 8x minus 12. You can graph that original function. Don't even worry about synthetic, and it'll tell you where it crosses, and you can just pick the right multiple choice that has those areas. All right, number 12. Remember, if you do this, I will cry on the test. It is big time, not equal to 9x squared plus y squared, super not. It is a binomial squared. You are multiplying the binomial by itself, okay? So you would distribute 3x times 3x is 9x squared. 3x times -y is -3xy. Keep it going. Keep it going. This would be my answer. Okay? But also remember, we looked at those multiple choice options on that miscellaneous sheet I gave you, number 3 and 4, I'm pretty sure. And it's going to be multiple choice option, and it's not going to look exactly like that. It's going to be a little different. So remember, I told you that if you have the quantity a minus b squared, it's going to always multiply out to be a squared minus 2ab plus b squared. Always, always, always. It doesn't matter what these numbers are, it will always multiply out to be that. So if you can multiply it out using this form, it's going to be a little bit easier to see which multiple choice is your answer. So a squared minus 2ab plus b squared. This is how your multiple choice answer is going to look. It's not going to look like this, it's going to look like this. Now yes, these are the same thing. 3x squared is 9x squared. 2 times 3x times y is 6xy. Y squared is y squared. They are the same thing, but remember the notation they're going to use on the test is going to look like this. Okay. 13. Three plus 9x squared divided by 3. Again, I am squaring this binomial, I am multiplying it by itself. So I write it twice. Anytime you see a squared, you should write it twice, because that's what it means. 3 times 3 gives me 9. You can use the same thing I showed you, the a minus b quantity squared, you would just put plus. Instead of minus 2ab, it'd be plus 2ab. You can use that for this too to skip ahead, but if you're still not comfortable with that, I'm going to show you fully distributing. Okay, 3 times 9 is 27x. 9 times 3 is 27x. 9 times 9 is 81x squared. You're going to combine like terms. Now you're just going to divide every single term by 3. 9 divided by 3 is 3. 54 divided by 3 is 20. Nope, JK. 18x. 81 divided by 3 is 27x squared. And that is the multiple choice answer you look for. All right, number 14. Chuck is putting up a fence to create a rectangular field. Well, if there's a rectangular field, the fence is probably rectangular. The width of the field is x, where x is in feet. The length of the field is 10 more than the width. Write the function a of x that describes the area in square feet as the function of the width. So remember, area is length times width. So I'm just going to take my two pieces and multiply them together. Okay, I will accept either of those options. Either will work for me. You don't have to fully multiply it out. You can leave it like that. It's fine. Remember, if it's a square, then the side lengths will be the same. Okay, side lengths will be the same if it's a square. Okay. Okay. This is going to be 15 through, we'll see. All right, number 15. It just says to factor each expression completely. Remember, you're always going to check for a GCF. That's your first step when factoring no matter what. So you should notice that both of these numbers are even for 1 and they both have an x. So that means I'm at least pulling out a 2x. I pull out a 2x as my GCF and I get x squared minus 36. You should at this point recognize that that is a difference of squares, which we talked about. The difference of squares is going to factor to a plus b times a minus b. So I'm going to ignore this 2x GCF for right now because it doesn't matter. What did I square to get to x squared? I squared x. What did I square to get to 36? I squared 6. So this is going to factor to x plus 6, x minus 6. And don't forget to tack on your GCF. Number 16. here. Pull out a GCF first. It's not wrong if you don't, but you can definitely pull a GCF out first. 25 goes into both of those. This is a difference of squares, yes, but so is this. That's going to factor to x plus 2, x minus 2, and put a 25 out in front. If you don't pull a GCF out first, then you would have gotten 5x plus 10 and 5x minus 10. Again, it's not wrong, but you always want to check for a GCF first. Number 17. This is factoring a trinomial when a is greater than 1. So I'll show you the box method and bottoms up. So the box method, remember, goes like this. You're going to put this here. You're going to put your last term here and your middle term down here. So I'm going to put my factors of 2x squared in here, which is 2x and x. And my factors of 5 are going to be here, which I could do 5 and 1, but that's going to give me 10 and 1, which do not make 7. So I'm going to switch that to 1 and 5. This gives me 2x. This gives me 5x, which gives me 7x. That's what I wanted. Circle this and get 2x plus 5. Circle this and get x plus 1. And it's factored. Now, you can do bottoms up. Bottoms up, I take this first number, I multiply by the last number, and I get x squared plus 7x plus 10. I then say what multiplies to 10 and adds to 7. That's x plus 5 and x plus 2. Because I multiplied by 2 in the beginning, do not forget to divide by 2 at the end. 5 does not divide by 2, so I bottoms up. 2 divided by 2 is 1. Notice I get the same thing. Either way works. Number 18. You should recognize that all of these are even, which means it has a GCF of at least 2. Well, 2 is going to be our GCF here, so I'll pull the 2 out. 3x squared minus 5x minus 2. Now, I'm ignoring the 2 for a second. I'm just looking at that inside. I'm going to have to bottoms up or box method. I'm going to do bottoms up. There's videos of box method if you want to see that. But I'm going to do bottoms up just for time's sake. So, 3 times 2 gives me x squared minus 5x minus 6. Two numbers that multiply to negative 6 and add to negative 5 are negative 6 and positive 1. I multiplied by 3 in the beginning, so I divide by 3 at the end. 6 divided by 3 is 2. 1 can't divide by 3, so I pull it up. And don't forget my 2 GCF that I pulled out in the beginning. Number 19. Here you should recognize that you have an x cubed, but you don't have an x over here, which means it's probably going to be a difference of cubes. However, you should notice that 10 and 80 are not cubes, but you should also notice that there's a GCF of 10. So I can pull a 10 out. That gives me x cubed minus 8. That is a difference of cubes. 8 is a perfect cube. I can do difference of cubed. A minus b, a squared, ab, b squared. Okay, that was on that list of formulas I told you should know. So what did I square to get to x squared? What did I cube, to get to x cubed? It was x. I cubed 2 to get to 8. So that means I do x minus 2, x squared plus 2x plus 4. And I bring my 10 down from my GCF. All right, number 20. R to the 6 minus q to the 6. We did a few examples like this. Remember, when you have to the 6 exponent, you were always going to do difference of squares first, then you're going to break it down to difference of cubes. So think 2, then 3. So what could I make r be that if I squared it, it would get me back to r to the 6? Well, r cubed squared is r to the 6. Same goes for q cubed squared. So I now have a difference of squares, which we looked at earlier. I'm going to A plus B, A minus B. So A plus B, A minus B, okay? In this situation, this was my A, this was my B. Now I've got the sum of cubes and the difference of cubes. Remember, they factor exactly the same. The signs are the only part that's going to change. So I do A, B. A squared, AB, B squared. I'm going to have those exact two parentheses again for the difference of squares. A, B, cubes, sorry, difference of cubes. A squared, AB, B squared. Now for my signs, I just look at my original. So I do same, opposite, always positive. Same, opposite, always positive. And I'm done. That's factored. Okay, 21. Alright, 21 looks like the ones on those miscellaneous sheets that we did. There were a couple, I think it was 15 and 16, somewhere around there. It's going to be a select all, okay? And yes, you can synthetic division, but it's not going to help you when you actually are looking for your select all options, alright? This is going to want you to put f of x over g of x, simplify, see what cancels, and that's what it's going to want from you. So I'm going to do f of x, which is 4x squared minus 10x minus 6 over x minus 3. So the first thing you're going to want to do to the numerator is you're going to want to factor. You should notice there's a GCF. I'm going to pull out a 2. 2x squared minus 5x minus 3, all divided by x minus 3. Now I'm going to go ahead and bottoms up this. So I take 2, I multiply it by the back, and I get x squared minus 5x minus 6. Two numbers that multiply to 6 and add to 5 are going to be negative 6 and negative 1. I multiply by 2 in the beginning, so I have to divide by 2 at the end. 6 divided by 2 is 3. 1 does not divide by 2, so I get 2x plus 1. So that means this becomes 2 times x minus 3 times 2x plus 1. All divided by x minus 3. Notice, I have an x minus 3 in my numerator and x minus 3 in my denominator. That is supposed to happen. If it doesn't, you did something wrong. Okay? I'm looking for the answer that has a factor that's going to cancel out of both. That's one of my select alls. So that is one of the options you're going to choose. Once they cancel, you're just left with 2 times 2x plus 1. This is also going to be one of your answers you're going to choose. If I were to distribute the 2, I would get 4x plus 2. This is also one of the answers you're going to choose. You're going to have 3 different answers for the select all question. Be watching out for that. 22. Find each quotient. Remember, if I'm dividing by x squared, it has to be long division. So x squared plus 2x minus 5. Dividing into 6x to the 4th plus 5x cubed. I don't have an x squared term, so I have to put a placeholder for it or I'm going to mess myself up. Don't forget about the placeholder. What multiplies x squared to get to 6x to the 4th? It's 6x squared. I take this and I multiply by everybody on the outside. So 6x to the 4th, 6x squared times 2x is 12x cubed. 6x times negative 5 is negative 30x squared. Remember, I'm subtracting this, so all of the signs will change. This cancels. 5 and negative 12 make negative 7x cubed. 0 and 30 make 30x squared. And I bring down my 2x. You can bring down your 8 if you really want to. What do I multiply x squared by to get to 7x cubed? That is negative 7x. Negative 7x times x squared is negative 7x cubed. Negative 7x times 2x is negative 14x squared. Negative 7x times negative 5 is 35x. I'm subtracting, so all of my signs change. That cancels. 30 and 14 make 44. 2 and negative 35 make negative 33x. And I bring down my plus 8. What times x squared will take me to 44x squared? It's 44. Multiplied by everybody on the outside. but I'm subtracting, so all of my signs change. Cancels, negative 121x plus 228. Okay, I can't go any further because there's no number that I can multiply x squared by that will take me down to just x. So my answer is 6x squared minus 7x plus 44 plus my remainder divided by my divisor. Okay, all right, 23. Alright, so this is the one I was talking about in class that you will get a fraction on. I don't think there's a fraction one on the test, but I honestly can't remember. So 4x minus 3 goes on the outside. I'm dividing that into 4x cubed plus 12x squared. I don't have a 0x and I don't have that 0 term, so I'm just going to put them on at the end so I don't forget them. What do I multiply 4x by to get to 4x cubed? That's x squared. 4x squared times 4x is 4x cubed, and minus 3x squared. All my signs change because I'm subtracting. Cancel, and I get 15x squared plus 0x plus 0. So this is what I was talking about. There's no whole number that's going to multiply by 4 to get to 15. It doesn't have to be a whole number. It can be a fraction. So what I do is I say, okay, 4 times what will give me 15? And I can solve for that what? The way to get to the way to get to 15 with a 4 is to multiply by 15 fourths. Does that make sense? 4 times 15 fourths. Those will cancel and leave me with just 15. Yes. Okay. So I'm going to multiply by, I got to get to x squared, so 15 fourths x. Multiply that out and I get 15x squared. That's what I wanted. That's going to give me negative 45 fourths x. But all my signs change. Cancel 45 fourths x plus 0. I'm going to do the same thing I did over here. 4 times what will give me 45 fourths. I can divide by 4. Dividing by 4 also means multiplying by the reciprocal. So it would be 45 eighths. So I'm going to multiply by 45 eighths. 45 eighths times 4x is 45 fourths. And times negative 3 is an icky number. Did I get that? No, I didn't. Okay, hold on. 45 eighths. Like I said, I don't really think you'll have one like this on your test, but just in case. And you get 135 eighths. All my signs change. 135 eighths is going to be your remainder. Okay? Really icky, but I'm like 90% confident you won't have one like this. All right, and number 24.
Might need to stop that 15
What?
minutes. Do you think we should make another one?
It's just really quickly.
Okay.
All right, this one is synthetic division. 24. I'm going to put the opposite in my backwards box. Oops. Which is positive 1. I'm going to write all my coefficients. Drop it. Multiply. Add. Multiply. Add. This is my remainder. So I get 3x plus 1 plus 6 divided by x minus 1. That would be my answer. All right, number 25. The polynomial h of x is divided by a binomial. The result is shown. What is h of x? So you see x squared plus 3x minus 2 plus negative 19 divided by x plus 3. Okay? So remember, this is my quotient. This is my remainder. And this is my divisor. So if I had it set up, this is what it would look like. Okay? We're basically working our way backwards to find this original polynomial that we divided into. all you're gonna do is you're gonna multiply these together and you're just gonna subtract that 19 off. So I'm gonna multiply my quotient and my divisor. And I'll take off 19 at the end. So x times x squared, x cubed, 3x squared, minus 2x, 3x squared, 9x, negative 6, and the minus 19. Now it's about combining like terms. X cubed, x squared, and x squared gives me 6x squared. Negative 2x and 9x gives me 7x. Negative 16 and negative 19 gives me negative 25. So this is my original polynomial that I divided. Number 26. Number 26 says, what is the remainder when blah, blah, blah is divided by x minus 8? So you're just going to do synthetic division. You can do long division if you want. It's okay. It'll work the same if you don't make any mistakes. So I'm dividing by x minus 8, so I put the opposite in the backwards box. I write the coefficients out, 7, negative 4, negative 400, negative 100. Drop it down, multiply, add, multiply, add, multiply, add, 128, and I get 28. So my remainder is 28. And that's all. It's not asking you to do anything else. It's simply asking for the remainder. And you're done. 27. Says, is x minus 2 a factor? Why or why not? If it's a factor, use the results to find the remaining factors. Remember, if it's going to be a factor, that means it's going to have a remainder of 0. So you're going to divide. If it has a remainder of 0, it's a factor. If it doesn't, it's not. So I put the opposite in my backwards box, which is a positive 2. I write my coefficients. Drop, multiply, add, multiply, add, multiply, add. I have a remainder of 12, meaning it's not a factor. And I move on. No big deal. This is multiple choice on your test, and it's like, yes, remainder 12. No, remainder 12. Yes, remainder 0. No, remainder 0. You just have to come up with the correct answer and the correct reasoning is all. So you would be looking for no, because the remainder is 12. All right, write an equation for a function that has a root of x equals negative 2 and has the same two roots as x squared minus 5x minus 6 equals 0. Remember, roots are a fancy word for zeros, intercepts, all that stuff, okay? So there's a couple ways you can do this. You can factor this, x minus 6, x plus 1, set them equal to 0, get x equals 6, x equals negative 1. Then you can look at your multiple choice options and say, graph them all and say, okay, which function crosses at negative 1, 6, and negative 2? You're going to see which function crosses there. All right? You just have to plug them in, see which one was right. Or you can undo this, put it into factor form, which would be x plus 2, multiply it by what you had left, and that'll give you your original function. So x times x squared, x cubed, negative 5x and 2x make negative 3x squared, negative 6x and negative 10x makes negative 16x, and negative 12. This would be the function you would look for. Me personally, I think this is faster than doing that and then graphing and then looking personally, but you do you. You do you. 29. Completely factor. Alright, so this is grouping. We're going to split it right down the middle. And I'm going to put a parentheses around my first two and my last two. I'm going to put the negative in the middle, which means my sign changes after the fact. Here's another way you can remember that your sign is going to change. Remember that when I pull a GCF out, this parentheses and this parentheses has to be the same. If this was addition and this was subtraction, they wouldn't be the same. So you have to change the sign. The GCF right here is r squared. That leaves me with r plus 1. The GCF here is 4. That leaves me with r plus 1. They're the same. They're supposed to be. The numbers on the outside will be in a parentheses together, and then you'll tack on the r plus 1 at the end. You're not quite done. Remember, this is a difference of squares. So it's going to keep going to r plus 2, r minus 2, r plus 1. That's going to be your final answer. This is multiple choice, so hopefully it'll help with knowing what your answer is. All right, and number 30. A polynomial p of x is divided by 3 different linear expressions as listed in the table. The remainder of the division after the division by each linear expression is also shown in the table. What must the root of the polynomial be? So you're given some table. We were divided by x and we got -1 as a remainder. We divided by x minus 4 and we got 0 as a remainder. We divided by x minus 6 and we got 2 as a remainder. So remember, for something to be a factor, it has to have a remainder of 0. There's only one that had a remainder of 0, which means whatever our polynomial was, we don't know and we really don't care. X minus 4 was a factor. That's great and dandy, but remember, if that's the factor, you have to set it equal to 0 to find where it actually crosses the axis. So to find the actual 0, the actual root, you would set it equal to 0 and solve. So the root is x equals 4. Remember, I told you in class that it's going to have the options of -4 and +4. Remember, you're going to have to take the opposite or you're going to get it wrong. This is just the factor, but to find the actual 0 or the actual root, set it equal to 0 and solve, or take the opposite. All right, I know that's the end of your review, okay, but when I was looking on the test, there are some review questions on the test that didn't quite make it on your review. I should have looked harder, that's my bad, okay? But I'm gonna go over some questions that you're gonna see in the review section. Just to give you some questions, and I'll upload the questions that I go over also as part of the key. All right. Okay, these are the review questions. We'll call this the extended edition. Sorry, my handwriting is trash. Okay, so we'll call it 31. You're gonna have a question where we've already kind of talked about increasing or decreasing, so this isn't really a review question, but it wasn't on the review, so I want to make sure that you knew it was gonna be on there. So remember, we had the little check mark box and you just had to check if it was increasing or decreasing. Well, we changed it on the test to be multiple choice. So each function is a question and you just have to circle A for increasing or B for decreasing. Determine whether the following functions are increasing or decreasing. So let's say you've got f of x equals -3x squared plus 2x minus 4. G of x equals 3x cubed plus 2x squared minus 6x plus 7. And h of x equals -5x to the 5th plus 6x to the 4th. Remember, we're talking about increasing or decreasing. We're looking at these first coefficients right here. So if you had to say if this was increasing or decreasing, you would see the negative and you would say, hey, that's decreasing. If you had to pick whether that was increasing or decreasing, remember that's the cubic function, and it's done that general increasing motion. So we're going to say increasing. Looking at this, if you had to pick based on positive or negative, you'd say decreasing. Okay? The easiest way to answer this problem is just to look at this first number. If it's positive, it's increasing. If it's negative, it's decreasing. Okay, 32 on the extended edition. Alright, it's going to say, use the discriminant to determine the number of real solutions of -2x squared equals 6x plus 8. Remember the discriminant, which I put on that the formulas that you would need to know, the discriminant is b squared minus 4ac. It's just what's under the radical in the quadratic formula. So don't memorize this discriminant and the quadratic formula. Just memorize the quadratic formula, and then you have it in the quadratic formula. So it's what's under the quadratic formula. We're going to plug in to see what the discriminant is. Remember, it has to be set equal to 0 first. So 2x squared plus 6x plus 8, that's equal to 0. A is 2, B is 6, C is 8. So I'm going to do b squared minus 4 times A times C, that's 36, minus 64, which gives me negative 28. Remember, if my discriminant is negative, that's what's under the radical, which is going to give me 2 imaginary solutions. Okay. So, if it's positive, it would be 2 real solutions. If it's equal to 0, it would be 1 real solution. But the discriminant gave me negative, so 2 imaginary solutions. 33. Write the equation of a circle with a center at negative 1, 3, and the radius is 8. So I gave you the equation for a circle that you'll need to know. Remember, you just take the opposite of your vertex and you square your radius. So I'm going to do x plus 1, y minus 3, and 8 squared is 64. Easy as that. Number 34, okay, you're going to be asked to sketch a graph. You're going to be asked to sketch a graph. So, f of x equals negative x minus 2 squared, x plus 1, x minus 3 squared. So, here's the things that you should notice. Now, everything about this is going to look like you're going to see tomorrow. The numbers are just going to be different. That's all that I changed, okay? Because I know it's been a while since we graphed polynomials. So this is an x squared, and then 3, and then 2 more. This is going to be a 5th degree polynomial. It's negative, which means it's going to have this overall shape. It's going to start up and end down. It's going to cross at 2, and it's going to have a bounce right there. That causes a bounce. It's going to go through at negative 1, and it's going to bounce again at positive 3. So, going through at negative 1, bouncing at 2, bouncing at 3. I start high, bounce, bounce, and end low. That's it. It's just a rough sketch. 35. You're going to have a vertex question. It's going to ask you to put an equation in vertex form. So let's say I got this equation. 3x squared minus 6x plus 10. I always start with the opposite of b divided by 2a. So opposite of negative 6 is 6 divided by 2 times 3. I get 1. Remember, you take 1, you plug it all the way back in for x. 1 squared times 3 is 3, minus 6 plus 10 gives me 7. So if I'm plugging it into my vertex form, A is the only thing that's the same between them, so I'll put 3. Remember, H is opposite, so I'm putting x minus 1, and then my plus 7. And that would be my answer. Okay? It's going to look like you did on your quiz and your first test. It's going to have the blanks. Okay, should look familiar. All right, and the last one that we have on there that is not on your review is a quadratic formula 1. A quadratic equation has the coefficients of a equals 3, b equals negative 4, and c equals 5. Find the solutions. At this point, it already gave you a, b, and c. All you have to have is a quadratic formula. X equals the opposite of b, plus or minus the square root of b squared minus 4ac, all divided by 2a. The opposite of my b is positive 4. B squared. Make sure you're putting b in parentheses, guys, or you're going to get the wrong answer. On your quiz, I guess it was last week, a lot of us did the quadratic formula right. We had the right equation, but we did not square our negative number in parentheses, and it gave us a positive number, and that messes up all under the radical, which makes the whole problem wrong. So negative 4 squared minus 4a c, all divided by 2a. 4 plus or minus positive 16 minus 60 divided by 6. Oops. Oops, okay. And we're back. 60 minus 4 gives me a negative 44. Okay. Remember, all I expect you to do is be able to pull out the I. So because it's negative, it has an I. If you get here, I'm good. All right, but if you want to break it down further, 44 breaks down to 4 and 11. The square root of 4 is 2. So this would go to 4 plus or minus 2i square root of 11 over 6. If you get here, I'm good. Or you can say 4, 2, and 6 are all even, so they can be divided by 2. So 2 plus or minus I square root of 11 divided by 3. I will take any of these. If you leave it with the negative, you are getting it wrong. Just pull the I out. That's all. That's all you have to do. Okay. And that's pretty much what you're going to see tomorrow. I hope this was helpful. I hope you look at it and you learn, and I'll see you tomorrow. I'll answer a few questions, but not a ton because I answered a lot of them right